Let's call this one Tales of Industry. You hear a lot of conversation about automation and what it's doing. So here's a little bit of our history from 1980s. I had left the chemical industry. I was unemployed for a number of months, moved the family up to Pennsylvania, and ended up getting a job back in Maryland. So moved them all back down there. But the job was traveling, so I ended up traveling extensively. This was a conveyor company, one of the largest in the world, made chain and cable, and they had gotten into the automatic guided vehicles business. So an AGV, automatic guided vehicle in industry terms, is something that gets around automatically. So it could be on a chain drug around with a bunch of different paths the chains can take to move things around, or in this case it was automatic guided vehicles. This was let's say a 10-ton, just because I don't remember the hard number, electric forklift type of vehicle. It carried a flat around on it, a tooling flat for welding automobile bodies together. So these things followed wires around in the floor, set a pallet down an automation cell that was full of sheet metal, and then welding robots would go after and weld, or other robots would add parts to it. So when we came into GM's body shops, and I was working with 4 systems at the time, but had primary on 2 that were sister systems, very similar architecture. So the other 2 systems were very related, only different guided vehicle systems, same electronics. So we had a huge industrial forklift battery in there. I had 110 of these vehicles to get working in a manufacturing system GM had never tried or deployed before. So again, what these are is if you can think of about maybe a 14-foot long forklift. You can find pictures of them. You can find news stories about when General Motors flew these AGVs over from Torino, Italy, from a company called Fada, and GM had to use their own 747 fleet that they had built to carry cars from Italy to America. And since they had them and there was no other freight available to get the vehicles, those automatic guided vehicles, to America, GM retrofitted those 747s and flew the AGVs to America, and they got off the plane, and then we finished putting them together and started making them work. By we, I mean a team of engineers from Germany, France, and Italy primarily were together on this one. So I'd worked with German engineers in a chemical industry, so I had some feel for professionalism, I guess you would put it. So a lot of respect for work ethics and education for those folks. France, the French engineers, 80's Electronics, same way. They made the electronics boards for a good portion of this. So multiple vendors inside of this one AGV. The plant I was working with, primary assignment, had 120 of these electric vehicles running around. This is before you knew electric existed. So they followed a wire in the floor, and there were different configurations of the wiring, so it knew where it was. Through its travels, there were roughly 200 points in a very large circle that these vehicles could go through. There were crisscrossing paths, so it was an asynchronous manufacturing system, which was new to General Motors. So we had to build, our goal was to be able to build over 60 jobs an hour, and after about a year and a half of tuning, I had the system up to about 72 jobs an hour. So that was, just years of work, because the technology, even though we got it as brand new, it was already dated and struggling and could have been done better. So you see the opportunities for improvement every time you step into some of these engineering positions. So anyway, when I came in, General Motors was making a transition to to asynchronous manufacturing. And that means that you don't get a standard build sequence. You don't say build number 1, build number 2, build number 3. You might say build number 200, build number 5, build number 7. Oops, I need 200 in front of 5 and 7, but I already, so you can reschedule and resequence things in certain areas. So a lot going on with this asynchronous manufacturing stuff. So parallel lines make for tough decisions and can upset a schedule. If I build in the body shop, I've got to order an engine over for the engine line sometime in there. So lots of effects of going to new manufacturing processes, and lots of training, because at that time no one knew what a PLC was. So I came in and I trained electronics, I trained typing, I trained intro to computers, I worked with skilled trades to make them more skilled, and I worked with management to show them what they had bought and help them understand. So when a work cell came in, these work cells replaced a lot of people. The ratio of displacement was, I want to say 60% of the workforce got displaced by my automation stations. So in body shop areas, in high risk areas, a lot of automation was put in, because getting the people out of those areas was just the right thing to do. You can rationalize why a lot of the automation things were done. And don't forget, while I'm putting in new robots and automation, overhead is going one of the largest air cleaning and air handling systems probably in the state, because of the size of the facility, and it's all meant to get dust out of the air from welding so that people don't get it in their lungs. So the amount of engineering and expenses put into making the environment safer for people to be in was huge. Now, why would you do that? Well, my stations were welding stations. They were welding stations in the old line designs that had a person with a weld gun, or a person with maybe 2 weld guns, depending on, a 2-door might need a different weld gun than a 4-door, because the car's different. So they might have to make a selection for the job coming up, or they might not. So my robots came in and had to make these same choices, had to be able to make the same choices, or had to be able to pass. They didn't have a job to do, so they say, it's a 4-door, I can't do anything. Or it's a 4-door, I swap the tool. So I go from a little weld gun to a long weld gun. So that's overview of one automation station. I had responsibility for all hundreds of them overall in the process. For the equipment, the production was somebody else's responsibility, so I had to help them through some of those processes, and they helped me, because it was a give and take. My process had to work for their business, which was building cars. They knew the business, I knew the process, the new process, so I helped them to marry. But through